everybody. I'm Fabiola Cavaliere and I'm a PhD student at UPC in Barcelona. Today I want to tell you a little bit about my project, and I will start by asking you a question. Do you know that if you were a car designer, you should wait up to 4, 5 or more years to see your initial sketch becoming a real car? Yes, designers are really patient, and that's why I'm trying to help them with my research. More in general, I'm trying to deal with a topic which is quite interesting nowadays for the industry, and this is design optimization. Yes, because industries spend a lot of time in designing the products more than in producing them, and this means that they spend a lot of money on that as well. Think about a car. This is a very complex structure. It is made out of thousands of components that all together have to respect a lot of requirements. We want to have stylish car, but safe ones, comfortable, eco-friendly and whatever. For this reason, every day several engineers have to cooperate and continuously change and readapt the initial design until they find the best solution. I really want to help the industry with my work in finding a best way to reduce time and cost consumed during the design process. To make things easier, I want to start from a simple case, and I want to try to optimize the design of my car with respect to only one target, which is the so-called noise and vibration test. In few words, this is a test where engineers make sure that vibrations and noise don't affect the comfort of the driver. The interesting part is that vibrations in particular are really sensitive to any change in the initial design. So how do we solve this kind of problem? First of all, as engineers, we make use of computational simulations. This means that we can create some virtual models in which we define all the characteristics of our problem, and then we give it to the computer that will solve it for us, basing, of course, on very complex computational and mathematical theories. So let me give you an example. Let's assume we have a very simple structure like the one you see on my side, and that we want to check how changing its shape could change the result. The problem here is that designers don't know from the very beginning what are the characteristics of their car. This is actually what they want to find out. So using standard approach, the way they do it is to simulate the same problem several times for every time they change the initial condition. Then they will study all the collected results and find the best solution. This process is very time consuming. So what I want to do with my project is to propose a good alternative to that. Let's imagine we can tell to our computer, please, you have to find for me the best solution if I tell you that I want my geometry to change in a certain range. With the new methodologies I'm working at, we're actually able to do that with only one simulation and get all the possible solutions in this range we chose. At this point, what we got from this simulation could be uploaded as data on smartphones or tablets, where designers could simply play around with all the parameters until they can see in real time what is the best result. Don't you find it a little bit revolutionary if you think that this method can be also applied not only to cars but to any engineering application?